Hello class, welcome to today's lesson, which is the second part of the solution to trigonometric equations over a finite interval. Today we're going to get to know the meaning of that phrase, guys. The meaning of this phrase, over a finite interval. Okay, so let's get started. Today, guys, we're going to use also the trigonometric functions of angles in the second, in the third, and in the fourth quadrant. Because I don't know if you realize this, but all the equations that I gave you for the workbook, all these equations, for all of these, you only had to make use of the trigonometric functions. By the way, ignore this, the cotangent, that's a function that we don't use in this semester. So sine, cosine, and tangent, we only considered the sine, the cosine, and the tangent of these angles in here, from 0 to pi over 2 radians. Okay, so only positive values, like you can see. But now we're going to start using the trigonometric functions of all the rest of the special angles, which are this, and this. And no, there are actually more. Okay, it's represented better in here in this image. I'm gonna also put this image in this workbook, and these are all the functions, guys, the trigonometric functions of these special angles: pi over 6, pi over 4, pi over 3, pi over 2 to pi over 3, etc. All the angles in the second, third, and fourth quadrant can be understood as multiples of these 5 angles, from 0 to pi over 2. So that's it, basically. And remember that the last definition that I gave you, for the trigonometric functions of an angle was in the unit circle, right? Like the unit circle is a circle that happens to have a radius of 1. So from here to here, there is 1 unit. And if you want to take, or if you want to find the trigonometric functions of any angle, theta, you just draw it in a standard position, like I just did. And then you draw the terminal side. This terminal side intercepts the circle at a certain point with coordinates x, y. And the functions of this angle are defined as follows. The sine of theta is just the y coordinate. The cosine of theta is just the x coordinate. And the tangent of theta is y over x. And this is the last definition that I gave you for the trigonometric functions of any angle in regards to the unit circle. I also told you that this definition is compatible, or it's just an expansion of the 2 previous definitions. So that's how it works. Okay, so basically, when you look at, well, give me a moment, please. Well, let me erase everything. When you look at this image, basically what this image conveys is this, guys. For example, let's look at this angle of 150 degrees. Remember, we have to get used to the radian conversion of this angle, which is 5 pi over 6 radians. And the point that this angle intercepts in the unit circle is this, minus the square root of 3 over 2, comma 1 over 2. So we say that the sine of 5 pi over 6 radians is just the y coordinate of this point, which is 1/2. This is the sine of 5 pi over 6 radians. And the cosine of 5 pi over 6 radians is just the x coordinate of this point, which happens to be this number, minus the square root of 3 over 2. So we're going to use this image extensively. Get used to it and try to spot the pattern. I already told you something about the pattern. Let me remind you very quickly. Look at just the signs of the angles from 0 radians to pi over 2 radians, which is this angle, this angle, this angle, and this angle. 0 can be put as the square root of 0 over 2, right? And 1 can be put as the square root of 4 over 2. And with this change, we can readily see the pattern, guys. Look at the signs of all of these angles. The signs go like this: the square root of 0 over 2, and then the next is 1, which is the same as the square root of 1 over 2, right? And then the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. I think the pattern is quite visible, and that's how you can memorize this whole thing. Although it's not necessary, but if you wanted to, you can. There's a very very straightforward pattern to assimilate. Okay, so let's get started, guys. I'm gonna show you 3 examples. So the first example is this. We want to solve the equation 2 sine of theta plus the square root of 3 equals 0. And now I'm gonna introduce this new concept of solving this equation over a certain interval. I'm gonna write this. Oops, once again. And I'm gonna explain to you what this means. So let me tell you how you're supposed to read all of this sentence in mathematics. Basically, what this is asking from you is to solve this equation that I already said. And then when you see a semicolon and then some other phrase like this, some other sentence like this, what you should understand by this is over the interval from 0 to 2 pi. Okay, so basically what this is asking, guys, is that you should consider only solutions for theta that are within this interval, within this interval of numbers from 0 to 2 pi. Now, you may be thinking, what is the difference between putting a bracket and putting a parenthesis? The difference is this. The difference is that when you see a bracket, that means that this number is included in this domain. And when you see the parentheses, the round parentheses, that means that this number is not included, but any number less than 2 pi is included. Okay? For example, let me give you another example. If you saw this, the interval from 1 to 3, like that. Okay, bracket 1, comma 3 parentheses. What does that mean? That means that this interval is comprised of all the numbers from 1 to 3, but excluding the number 3. Excluding the number 3. That is that you can put any number inside here. You can put, for example, the number 1 is in here. The number 1.5 is inside this interval. The number 2, the number 2.9 because it's less than 3. The number 2.99, which is also less than 3. The number 2.9999999, but not the number 3. The number 3 does not belong here. Why not? Because I'm putting this parenthesis here. That means that the number 3 is not included in this interval. That's how you read. That's how you understand the difference between the bracket and the parentheses. The parenthesis excludes this number. For example, another interval from 2 to 3. This interval is comprised of all the numbers between 2 and 3, but excluding both the number 2 and the number 3. So for example, is the number 1 inside this interval? No, clearly not, because it's less than 2. Is the number 2.5 inside this interval? Yes. Is the number 2.9 inside this interval? Yes. Is the number 3 inside this interval? No. And that's how it works. Okay, so that's what this means, guys. We need to consider only the solutions that are within this interval. Within the interval from 0 to 2 pi, excluding 2 pi. You can understand by the end of the lesson what that means. So let's get started. So as I told you in the lesson before, we need to start this type of equations by trying to simplify the equation into something like this: a trigonometric function of an angle being equal to some other value. If we can do this, do it. So let's get started. I'm gonna subtract the square root of 3. I'm gonna divide both sides over 2, and that's it. I have already achieved this form. Sine of something, some angle, equals a value. Okay. Now, for what angle theta do I get that the sine of theta is equal to minus the square root of 3 over 2? I go to my image, and since I'm dealing with sine, that means that I should look at the y-coordinates of all of these points, and I need to look for this coordinate, minus the square root of 3 over 2. So since that is a negative y-coordinate, I should look below the x-axis. Let's look. I have already one here, can you see? And the other is, no, I'm sorry, this is the x-coordinate. Getting confused. This is the y-coordinate, and it's minus the square root of 3 over 2, which is what I want. And this is the other one. Can you see? So for what angles does this correspond? For an angle of 4 pi over 3 radians and 5 pi over 3 radians. So my conclusion is that theta must be either 4 pi over 3 radians, or theta must be 5 pi over 3 radians. Now, these are my two solutions, guys. Now, what I need to do only is to ask myself whether these solutions are within this interval. Is 4 pi over 3 within this interval? Yes. Is 5 pi over 3 within this interval? Yes. So both are perfect solutions to this equation given this interval. We didn't have to, let's say we didn't have to cancel neither of these two solutions. Okay, so that was the first example. Second example, let's deal with this one. 4 times the cosine squared of theta minus 3 equals 0. In this case, I want to solve this equation over the interval, theta being a part of the interval from 0 to pi, excluding pi. Okay, so let's see. Same idea. I want to simplify this a little bit. So let's add 3 on both sides. There you go. Let's divide over 4. Okay, now this is a new addition, right? Something that we haven't worked before, which is a trigonometric function raised to the square. And as you may guess, what we need to do next, well, a good idea is to take the square root from both sides. So let's take the square root of this and the square root of this. If I take the square root of this, I get cosine of theta. That is, the square gets eliminated. And then I'm going to take the square root of 3 or 4. But remember that always, when you take the square root of a constant, you should account for the plus and the negative square root. Can you remember that? Okay, so now with this new, at this point now, what I must realize is that I have two branches, or this equation is gonna bifurcate. I don't know how to pronounce this word, so I'll bifurcar. I do believe it's the same in English. Bifurcate. I need to look at the pronunciation. Okay, so what this entails is this. I want to consider this equation for the positive square root. So cosine of theta equals the positive root of the positive square root of 3 over 4. Or I should also consider the cosine of theta being equal to the negative of the square root of 3 over 4. And now I should independently solve this equation and this equation independently. So let's do this first. I'm going to continue over here. So cosine of theta equals the square root of 3 over 4. Now if you remember, when you take the square root of a fraction, that is the same as taking the square root of both the numerator and the denominator independently. So what's next? How can I simplify this? Well, I know that the square root of 4 is 2, so I get down to this. Cosine of theta equals the square root of 3 over 2. And if you want to simplify this anymore, you're going to fail because there isn't anything else to be done. Okay, so I have the cosine of theta being equal to the square root of 3 over 2. At this point, I go to my image. And since I'm dealing with cosine, I should be looking at the x-coordinates of all of these points. The x-coordinates, which is this, and this, and this, and this, and this, no, and this, and this, and this, and so on. And for which angles do I encounter that the x-coordinate is equal to this? Let's see. Here's one for an angle of pi over 6. Okay, I keep looking, I keep looking, I keep looking. Here's another one for an angle of 11 pi over 6. So I have two possible solutions for this particular equation. I'm going to continue over here. I have the solution theta being equal to pi over 6, okay, or theta being equal to 11 pi over 6. 11 pi over 6. These are two possible solutions to this equation that comes from this equation, right? So I'm going to write in yellow the possible solutions to this equation in particular. We have theta being equal to pi over 6, or theta being equal to 11 pi over 6. Okay, we're gonna inspect each of these solutions, whether they satisfy this interval in a moment. I'm just gonna leave them here for a moment. And now I need to do exactly the same, guys. I already solved this equation. I need to now solve this other equation in the same way, the same exact way. So this is my equation. Again, I'm gonna continue here. Cosine of theta equals minus the square root of 3 over 4. Since I'm taking the square root of a fraction, that means, well, that is equal to the square root of each of those numbers. And I'm doing exactly the same. Can you see? This is minus the square root of 3 over 2. And I'm done. I cannot simplify anything further. Okay, so now all I need to do next is take a look at this image once again and investigate for what angles theta do I get that the cosine of theta is equal to minus the square root of 3 over 2. In other words, I need to look at the x-coordinates of all of these points for all of these angles, and I need to find minus the square root of 3 over 2. So let's get started. No, 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 yes. There it is for an angle of 5 pi over 6. Okay, so my first solution is theta being equal to 5 pi over 6. That's my first solution. Now let's keep on looking. Could there be another angle? Well, I was here, now this is the next. Oh, here it is. The same cosine for an angle of 5 I'm sorry, 7 pi over 6. So theta equals 7 pi over 6 is another possible solution. And these are my two solutions. If you keep on looking for another angle for which the cosine is this, you're gonna fail. It will always be only two possibilities. Okay, so the solutions to this particular equation are theta equals 5 pi over 6 or theta equals 7 pi over 6. So this is one, this is another one. Okay, now that I have, and by the way, I can erase all of this already. I don't need it anymore. I want to clean this up. Okay, cool. Now remember, guys, we are working with a constraint, within an interval. The author of, I'm sorry, it's this one. It's this one. The author of this problem will only accept solutions for theta which are within this interval from 0 to pi, excluding pi. 0 can be included, but pi can't. Now, all I need to do next is investigate each of these solutions and tell whether each one of them is in here or not, and just write as a final conclusion those which satisfy this requirement. So pi over 6. Is pi over 6 between 0 and pi? Yes. Why? Because this is 0 degrees, 0 radians. This is pi radians, which is 180 degrees. And we know that pi over 6 is this one, which is between 0 and pi. So this one is acceptable. Now 11 pi over 6. 11 pi over 6 is this much, which is outside the range from 0 to pi radians. You see? So this solution is discarded. This solution is excluded from this problem given this restriction or this interval. 5 pi over 6 is also within this interval because 5 pi over 6 is right here. And 7 pi over 6, which is right here, also falls outside this interval. So I'm done. What is my conclusion? My very, very final and wrapped up conclusion is this. The solutions to this equation over this interval, and all of those words could be written like the solutions to the equation over the interval from 0 to pi. Okay, I don't want to write this much. Are theta equals pi over 6 and theta equals 5 pi over 6. And this would be my very nice conclusion to this problem. So that's what it means to solve an equation over an interval. It means that only those solutions that fall within that interval in particular are going to be accepted. Any other solution, even though mathematically correct, will be discarded. That's what it means. Okay, and let me see how much time has passed. 23. Okay, we're gonna do another example live. Okay, because I don't want you to look at those very long videos like I always tell you, because it gets boring. So let's do one live, guys. Thank you so much.